Hello and welcome to yet another riveting video in geometry. This is Unit 4 and this is Section 6 and this is triangle congruence using ASA and AAS. So before we do anything, ASA, that stands for angle, side, angle, and AAS stands for angle, angle, side. Okay, so it's very similar to side angle side, what we did in the last unit, but we're gonna, we have other methods of showing that triangles are congruent. So we're going to identify side lengths that can be used to prove triangle congruency using ASA and or AAS. Complete the steps to prove triangles are congruent using ASA or AAS. And we want to determine the isometric transformations that would map one triangle onto another triangle given two pairs of corresponding angles and one pair of corresponding sides are congruent. So let's first start off with angle side angle congruence theorem. And so what we have here, okay, we have these two triangles, and the theorem states that, sorry, I'm trying to zoom in. The theorem states that if two angles and the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. So what I want to do is talk about this real quick, and I want to come up with the statements that we have. And what I know is that angle A is congruent to angle D. So I'm going to write that over here, that angle A is congruent to angle D. All right. I also know that segment AB is congruent to segment DE. Okay, so segment AB, okay, is congruent to segment DE. All right. The other thing I want to say that I know is that angle B is congruent to angle E. So angle B is congruent to angle E. Now, what I have here, guys, is I have an angle measure, pair of angle measures that are congruent. I have a pair of sides that are congruent, and another pair of angles that are congruent. And if I go around my triangle, what I have is I have an angle, a side, and an angle. Okay, same thing over here. I have an angle, a side length, and an angle that are congruent. And so when I go around and I say that, okay, this triangle and this triangle both have two angles and an included side, then I know that these two angles are congruent, or triangles are congruent. So I'm going to come over here and write my congruency statement and say that triangle, and I'm just going to say triangle ABC, okay, is congruent. Now, because I said AB, I need to line this up and say triangle DEF, okay? Because A corresponds with A corresponds with D, and B corresponds with E. So you got to make sure that you're dealing with corresponding segments, and I'm going to say triangle DEF, okay? And I'm going to say and that they're congruent by using angle side angle, okay? So now let's come over here, and we want to say, can we use the angle side angle congruence theorem to prove that the two triangles are in fact congruent? So here's what I've got. All right, I know that angle S, so I'm going to say this, I'm going to go angle S is congruent to angle T. Okay, I know that segment SU is congruent to segment TU. Okay, and then I know that angle SUV is congruent to angle TUW. So angle, and I'm going to come over here and do TUW, okay? And so because I have an angle, a side, and an angle, okay, I know that these two are congruent. And I'm going to come over here and I'm going to write in, okay, I have an angle, an included side, and another angle. Here I have an angle, an included side, and another angle to show that these are congruent using angle side angle. So my congruency statement, what I would need to say is that triangle SUV is congruent to, now we have to make sure these are corresponding. So S corresponds to T, so triangle T, okay, and then I said U, okay, here, U is just going to correspond with itself. So angle TU, and then we had V in the other one, and V corresponds with W, and so that's it. And we know that by side or angle, side, angle. Okay. Now, over here on this one, we want to show, are these two congruent? Okay, and so all we have, and I'm just going to write out what we know. Okay, angle E is congruent to angle N. Okay, I know that angle D is congruent to angle L, and I know that angle F is congruent to angle M. All right, now these are all just angles. Okay, I only have angles here, and I don't have anything with the side links. Now, they very well could be congruent, but I have no information. There is no information on the side links, okay? And so on the sides, so we can't conclude that they're congruent. So we don't know if they're congruent, if they are congruent. Okay, but we know angles are congruent. Now these we'll get into something called similarity later in the year, but right now, we don't know. Okay, so that's all we got. Okay, now let's talk about angle side congruence theorem. Okay, now that means that if you have if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. So angle, side. So let's come over here, all right, and let's just take a look at something. All right, I know that angle A, all right, let's do this. Let's do angle B is congruent to angle E, okay? I also know that angle A is congruent to angle D, not angle 4, angle A. And then I know that segment AC is congruent to segment DF. Okay? So I have an angle, and a side. Okay? I have an angle, and a side. I have an angle, and a side. So remember, it's about how you go, if you go around the triangle. Okay, you have angles, and then, you just say, okay, what do you have? What do you have that's in common? So I have an angle, and a side. This triangle has an angle, and a side. So I'm able to then conclude that triangle ABC, okay, is going to be congruent to triangle DEF, okay? Now, we can name this a number of ways, but we just want to make sure that the way we name them, that each of these correspond with each other. So A corresponds with D, B corresponds with E, and C corresponds with F, okay? And we know that these two triangles are congruent by angle, side, okay? And that's it, okay? I'm having a lot of fun. This is a good video. Okay, let's take a look at some proofs regarding angle, side, angle, and angle, side. And what I want to do over here is take a look at this, and let's write out, and I'm going to kind of zoom in pretty far and draw my table. Okay, and so here I've got statements, and I've got reasons, okay? And so the first thing I want to do, write up my given statement. So we're given that Kn is parallel to ML. So Kn is parallel to NL. ML, okay? And then the second thing I want to say is that angle K is congruent to angle M. So angle K is congruent to angle M, all right? And the reason why I wrote those two down, is because they're given to us, okay? It's around Christmas time. I hope you guys are, asking Santa for things. I'm really excited to see Santa. I'm probably going to see him this weekend, so I can tell him what I want for Christmas and stuff like that. So, yeah. All right, so these are given to us. It's like these gifts that are coming from nowhere. All right, so anyway, what we have, all right, if I know that, that these two lines, that Kn is parallel to ML, then what I can think about, and this is kind of hard to think about, but what I want to think about is if I were to extend these lines out like so, okay, and then think about this line here as a transversal, okay, then what I can conclude is that this angle here and this angle here are congruent. And the reason why I can say that is because they are alternate interior angles. So the third thing that I'm going to say here in part 3 is that angle KNL angle KNL is going to be congruent to angle MLN. Say MLN. Okay, and so I can say that because those are alternate interior angles, and that's from a previous unit, but those are alternate interior angles. All right, so then, all right, what I've got then is I have an angle measure, a side length. Oh, wait, no, hold on. Sorry. Okay, we don't know. Okay, hold on, we don't know that. Okay, the one thing I do know is that, because we have two angles, okay, I don't know if Kn is going to be congruent to ML, okay? We can't make that conclusion yet. However, we can say that NL is going to be congruent to itself. So the third thing that I can say here, the fourth thing, is that, NL is congruent to itself, NL, okay? And the reason I can say that is I have the reflexive property. Okay, and the reason why I wrote that down, okay, is because I'm trying to prove that these two triangles, LKN and NML, I'm trying to prove that this triangle is congruent to this triangle, but they share a common side, okay, and that's an important thing to realize, okay, is that they share a common side. So now that I have an angle measure, and a side length, okay, here I have an angle measure, and a side length, then I can show that these two are congruent. So I can then have my proven statement that triangle LKN, so 5, triangle LKN is congruent to triangle NML, And the reason why I can say that is because of AAS, okay, and we're done. That's it. All right. So, not too terrible, but, you just have to think about what you're given and where you're trying to go. All right. So now let's take a look at the next one. We are given that CBA is congruent. Ooh, this one's really easy. CBA is congruent to FBA. Okay. We also know that CAB is congruent to FAB. Okay. And we want to prove that triangle BCA, this triangle here, is congruent to triangle BFA. All right. So here's what I'm going to do. Okay, I'm going to come in here and I'm going to write down, draw my T-chart and write statements. Okay, and then reasons. So, okay, so the first thing I'm going to say is write down our given information. Okay, and that's that angle CBA. So angle CBA is congruent to angle FBA. Okay, and then the second one I'm going to say is that angle CAB is congruent to angle FAB. Okay, and the reason why is because you're given that information. So that's the reason. Okay, Santa's coming. He's coming for all of us. Okay. So I have an angle measure. Here's what I got. I got an angle measure and I got an angle measure here that are congruent to these other two angle measures. So now, all right, I don't know anything about the other side lengths here, whether they're congruent, but they share a common side length. So I'm going to come in here and say that BA is congruent to itself. So in part 3, I've got that BA is congruent to BA. Okay, it's congruent to itself. They share that common side. And the reason for that is because of the reflexive property. Okay, so now that I have an angle, an included side, and another angle, I have an angle, an included side, and another angle, then I know that these two triangles are congruent. So I'm going to say that in step 4, that triangle BCA is congruent to triangle BFA, okay, BFA. And the reason I can say that, and just because of how I labeled this, is because of angle, side, angle, angle, side, angle. So I'm going to say that that's because of angle, side, angle, okay? So that's that. All right, let's take a look at the last one, okay? Given, all right, on this one, you're given that angle T is congruent to angle U, and we know that S is the midpoint of TU. Okay, so let's write down that given information here. make our thing. So these are statements. These are reasons. Okay, my first statement is that angle T is congruent to angle U. Angle T is congruent to angle U. All right, and then that S is the midpoint of TU. So second one, S is the midpoint of TU. Okay, so, and the reason why I can say that is because they're given to us. Okay, and I wonder, who in fact gave us these statements as a gift from Christmas. Because Santa gave it to us. And you know what? He's checking this list over here, okay, to see who's naughty and nice. And I know who's been nice this season. It's been Mr. Police. But you know who hasn't been very nice is Mr. Smith, because he doesn't pay enough attention to me, okay? That's all I want him to do. I don't think it's that big of a deal. Oh, okay. Back to our proof. All right, so now, so what we have is that, we know that angle T is congruent to angle U. Okay, we know that S is the midpoint of TU. So if S is the midpoint of TU, then what we can conclude about that is that TS is congruent to SU. All right, so we have to think about, okay, if we're given this information, can we conclude anything from that? So let's write in step 3, okay, that TS is congruent to SU, okay? And the reason why we can say that is that's the definition of a midpoint. That's what a midpoint does. So def of midpoint, okay? And so then, the other thing that we can say, all right, just from this picture, is we have two intersecting lines. So I can come in here and I know that these two angles here are congruent because they're vertical angles. So let's write that, all right? Let's write that in part 4, that angle RST, okay, is congruent to angle VSU, angle VSU. And the reason why we know that those two angles are congruent is because they are vertical angles. Okay, and so since they're vertical angles, okay, I know I have a side length, or I'm sorry, an angle measure, an included side length, and an angle measure. And I have the same thing over here. I have an angle measure, an included side length, and an angle measure. So now, all right, so now I can just conclude that these two triangles are in fact congruent. And so step 5, I'm going to show my my proven statement. So triangle TSR is congruent to triangle USV, all right? And the reason why I can say that those are congruent is because of angle, side, angle, okay? And that's that. So, I just want you to pay attention to me, guys. Santa does. I know he does. And maybe, Mr. Smith could as well. So that's all I got. So hope you enjoyed this video. I had a lot of fun making this one. This one's really, really awesome. And so are you guys. See ya. Bye.